All right, here's another question about moments of inertia of a composite cross section. We have this, looks almost a little bit like a propeller, I guess you could say. And we are asked to find the centroid based on the corner down here. This time we'll actually just stick with that corner. And then also the moments of inertia and product of inertia through the centroid, which is shown here. All right, so of course we will need to divide this up. And I would say we divide this up as a big rectangle in the middle. And then another 2 rectangles and 2 triangles like that. And so we'll say the big one is 1. Then the rectangle here is 2. Stick with the other rectangle there is 4. 3, I'm sorry. At least I wrote 3. And then 4 and 5 for the triangles. All right, so we have 5 sections. I don't think if we did the full rectangle, we would still have 5, right? So if we did a big rectangle that covers everything, we'd have to cut out a triangle here, 1, a triangle there, 2, 3, 4, 5, right? So we would wind up with the same number, so we might as well just add instead of subtract. Means we don't have to worry about missing any negative signs. All right, so 5 sections. That's going to make for some big tables. So let's jump right in. For the centroid, we'll need I. We'll need AI. This is all millimeters. We'll need X bar I. Should have left so much space there. I think that was a little too much. YI bar. And then XI bar times AI, millimeters to the third. And then YI bar times AI, millimeters to the third. Oh, fit after all. And we need 5. 1, 2, 3, 4, 5. And then the sum. Make ourselves a nice big table. There we go. And then we can start our first shape, our overall rectangle. Let's see. That is how big. That is 5, 15 plus another 5 is 20. 20 times 2. 20 times 2 is equal to 40. Then my rectangles here would be 2 times 3. That's pretty easy. Equal to 6. The other one is the same. To 6. Then my triangles are 3 times 3 and a half. So 1/2 times 3 times 3 is 4.5. 1/2. Oop, that's not a half. That's a third. So we're not looking for centroids yet. 3 times 3 equal to 4.5. So that would be 9 plus 12 is 11. Is 11, yeah, no, 9, 22, 21, I'm sorry, not 11, and then 61. No sums here. Now for my XI, let's see if I start here for the big one. XI is just 1/2 times the length, so 1/2 times 20 is equal to 10. Then in the Y direction, I'd get 3 plus 1/2 of 2. 3 plus 1/2 times 2. That would be 4. For the triangle, for the rectangle here, I just go 1/2 of 1. Then 1/2 of 2, I'm sorry. is equal to 1, and the y direction would be 1/2 times 3. That is equal to 1/2. Now for the one over here, I have to, in the x direction, I have to add 18. So I have 18 plus 1/2 times 2. So that is 19. In the y direction, I have to add 5. So 5 plus 1/2 times 3. Why does it keep on doing that? Is equal to 6. Oh, 6.5. Not 6. 1/2 times 3, not times 2. Alright, number 4 is my triangle. So I have to have 2 plus 1/3 of 3 in the x direction. 2 plus 1/3 times 3. That would be overall 3. And in the y direction, I just do 2/3 of 3, going from the bottom up. 2/3 times 3 is equal to 2. Kind of squished in there. And then for the other one, in x, I have to go, in x, this direction is 15 plus 2/3. 15 plus 2/3 times 3. That is 17. And in the y direction, let's see, in the y direction, this is what I'm looking for. So I have to go 5 plus 1/3. 5 plus 1/3 times 3. That would be 6. That looks about right. All right, so then here I have 10, I have 1, I have 19, I have 3 and 17. For y, I have 4, 1.5, 6.5, 2, and 6. 6, 2, 6.5, 1.5, 4, 10, 1, 19, 3, and 17. All right, that all looks good. Then times the area, so that would be times 40, times 40, times 6, times 6, times 6, times 6, times 4.5, times 4.5, times 4.5, times 4.5. Let's make sure that we still know that's a 4, not a 9. 4.5. All right, so all I have to do is plug those in. 10 times 40 is 400. 1 times 6 is 6. 19 times 6 is 114. 3 times 4.5 is 13.5. And 17 plus 4 times 4.5 is 76.5. If I add them all together, 610. It looks nice. That's an easy division right there. 4 times 40 is 160. 1.5 times 6 is 9. That is 39. This is 9. And this is 27. And I add them all together, 244. All right, so our first table is set. So that means my x bar is going to be 610 centimeters to the third divided by 61 centimeters squared. 10 centimeters. Nice. That is good. And then in the y direction, we get 244. Ooh, this looks good too. I didn't notice that. Because this is 61, that's just going to be 4. Equal to 4 centimeters. Very nice. So we have two very straightforward numbers to do our subtractions with. All right, does that make sense? Let's see. Y would be on 4 up here. That makes sense, right? Because we can kind of say that there's a axis of symmetry if we just go through there. So it should be somewhere here. And in the x direction, what do we get? 10 centimeters. So it's just halfway through. Yeah, it looks very reasonable. All right, so now IX, IY, and IXY. New table. New day, new table. New page, new table, maybe. So we need I. We need X, I prime bar. Oh, this is millimeters, not centimeters. Oops. Let's fix that. Don't want any confusion there. So 600 millimeters to the third, millimeters squared, 10 millimeters, 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 and millimeters. There we go. Don't get any confusion there. All right, then we need to get rid of the C here as well. And millimeters. Millimeters to the fourth. I, not X again, but this time's Y. Y, I prime bar. Millimeters to the fourth. And I, xi prime, yi prime bar, millimeters to the fourth. And 1, 2, 3, 4, 5, and the sum. Oh, we need a lot of space on these. No, that doesn't look good. 1, 2, 3, 4, 5, and the sum. No, we don't need a sum on this one. Oh, we don't need a sum. The D's don't need a sum. These ones do. All right, so what do we have? We have triangles and rectangles, so they're all going to be in the x direction, bh cubed, otherwise h cubed, b cubed h. There we go, divided by 12 and divided by 36. So our big one, right, that had a width of 20 and a height of 2. So 20 times 2 to the 3 is a rectangle, so divided by 12. And that is equal to 160 divided by 12. Then the other one, the other two rectangles were 2 wide and 3 high. That is 54 over 12. We'll just leave everything as 12s and 36s because then we can see, you can add them as easy as possible. The other this one is the same. Over 12. 54 over 12. And these are triangles, so we're divided by 36. 3 times 3 cubed over 36. That gives me 81 over 36. Same thing here. 81 over 36. And if I add those together and simplify, I get 161 over 6. Now the y direction, it's easy, you just flip them around, right? So it's be 20 cubed times 2 over 12. That gives me 16,000 over 12. The next one would be 2 cubed times 3 over 12. That gives me 24 over 12. So 2. Same here. 2 to the 3 times 3 over 12. 24 over 12. Then we get, well, here it doesn't matter because they're both 3 over 36. 81 over 36. And then same here. 3 to the 3rd times 3 over 36. 81 over 36. And that, if I simplify it, is 8,051 over 6. All right, I, X, Y. Well, we know 1, 2, and 3 are all going to be 0 because they're rectangles. That's nice. 0, 0, 0. And then we have a couple triangles. Now let's see. Our triangle 4 has this kind of the corner to the top left. So that was a positive 1. So that would be positive 3 squared times 3 squared over 72. And that is 81 over 72. Now for the other one is the bottom right. So they kind of are corner to corner, so they're the same sign. They're both positive. So that one's also positive. 3 to the 3rd times 3 to the 3rd over 72. 81 over 72. So if I add that together, that would be 81 over 36. And I can simplify that and get what I get. 9 over 4. Something very nice and simple, just like we like it. All right, so these are our I's. I don't think we'll get the D's in the same section here. So how much space do we have left? Yeah, I think we have enough space left. So we'll just do one table per page, I guess. We'll do a lot of scrolling up and down. So again, I. Then we have dxi. And we said that is just xi bar minus x bar. Gonna be in millimeters. And the same for y. dyi is equal to x, not x, that would be easy enough. yi bar minus y bar. 1, 2, 3, 4, 5, and the sum. Yes, these big tables take a little persistence, but at least they are. Oh, we don't need the sum here. Yeah, whatever. We'll just leave it in there. Erase it. If we go back, it'll take us too long to recreate everything. So we don't need that. Oops. And there as well. All right. So that means we need our XI's. Lots of scrolling. 10, 1, 19, 3, and 17. I won't be able to remember that. 10, so you already forgot. All right, that's not too many. 119, 119, and then 3 and 17. And my X bar was 10. Minus 10 equals 0, minus 10 equal minus 9, minus 10 equal 9, minus 10 equal minus, I can do that a little bigger, minus 7, minus 10 equals 7. All right, that's good. Then here we have 4, 1.5, and 6.5. 4, 1.5, 6.5. and then 2 and 6. 2 and 6 minus 4. 4 minus 4 equals 0. 1.5 minus 4 is minus 2.5. 6.5 minus 4 is 2.5. 2 minus 4 is equal to minus 2. 6 minus 4 is equal to 2. All right. Very good. That means we are left with one more table and we're done. This is our I. Here we'll have dxi squared times ai, millimeter to the 4. We'll have dyi squared times ai, millimeter to the 4. And we'll have dxi dyi times ai, millimeter to the 4. And 1, 2, 3, 4, 5. Oops, that doesn't look like a sum. Make a little table. 4, 5. There and there. Now we need to find our dx's. dx was 9 minus 9 minus 7. So it was 0 squared minus 9 squared and 9 squared, and then was first negative, yeah, negative 7, no, negative 7 and 7, minus 7 squared, 7 squared. And then my areas, all the way in the first one, 46 and 4.5. Times 40 times 6 times 6 times 4.5 times 4.5. All right. That one's easy. That's 0. This is 486. The negative sign gets taken out. Same here, 486. Here we get 220.5. 220.5, total 1,413. All right, dy 0 minus 2.5 and 2. 0 squared minus 2.5 squared. Don't need a bracket there. 2.5 squared minus 2 squared and 2 squared times 40 equal to 0 times 6 times 6 times 4.5 times 4.5. That gives me the 0 we already have. This is 37.5, 37.5, 18 and 18, 1, 1, 1. All right. Now we have 0 times 0 times 40. We get minus 9, minus 2.5 and 6. We get 9 times 2.5 times 6. These are all symmetrical. We get minus 2 times, minus 7. That happens when you don't write clearly. Minus 7 times minus 2 times 4.5. And we get 7 times 2 times 4.5. And that gives me 0. That's easy. 135. 135, 63, and 63, and together 396. All right. With that, we are pretty much done. So we have I x prime bar is then going to be all our IX's. Where was that? 161 over 6. 161 over 6 millimeters to the fourth plus dy squared. That's 111. And that gives me 827 over 6 millimeters to the fourth. And that is 137.83 millimeters to the fourth. Then IY prime bar. Scroll up here, 8,051 over 6. 8,051 over 6 millimeter to the fourth plus 1,413 millimeter to the fourth gives me 16,529 over 6 millimeters to the fourth equal to 2,754.83 millimeters to the fourth. And then sooner or later I was going to do this. I x prime y prime bar was 9 over 4. 9 over 4 millimeters to the fourth plus dx dy a, so 396 millimeter to the 4. That gives me 1,593 over 4 millimeter to the 4, or 398.25 millimeter to the 4. All right, so we got through all of our tables and found the moments of inertia and the product of inertia based on the centroid of this green cross section right here.